It's great to have you here. Early morning session. This is something actually we're trying for the first time. So yeah, thanks for supporting us here. If you say good morning in the chat, that actually would be wonderful. Also, where you're from, that would be pretty cool. Last time we had someone from Taiwan and someone from Mozambique and so on. That is actually a pretty cool thing. So I actually need to type in hello from Berlin. And I know where Ollie is. Nunin from India, two from India.
Cool.
Cologne. Another one from India. Wow. Yeah, that's
right
the early morning. Exactly. I think this is the right time zone for India. That's pretty cool. But I think we're now 15 plus people.
Yeah.
That's always a good start. I think there'll be a couple of more people joining in this session. And today we'll talk about operate Kubernetes successfully. Welcome, Ollie.
Hello, Franz.
Yeah, Ollie actually works with customers. I do too, but he actually works more on a day-to-day technical basis. I'm more... Well, actually, we're both on a strategic level, but yeah, I tend to talk more about the business side of things. And today we'll actually put both our brains together, whatever we know from our customers, to share what what we want to tell you about how to operate Kubernetes successfully. So I think we should just get started. If you've got any questions, just type them in the chat. We'll both keep an eye on it. If we actually think it's better suitable to pick it up at the end, then we'll actually do it at the end. And we'll actually have always some time for question and answers at the end, which we are actually more than happy to engage with. So if you actually have questions, if you want to discuss anything, if you actually want to share a story, or if you actually completely disagree or agree with the point, actually, that feedback is really cool. We want this to be a very productive session for you. And I think without further ado, we actually can get started. What do you think, Ollie?
Yes, let's go.
Let's go. Okay, so the first slide that I kind of prepared is, I nicked it. But that's something you actually have been talking a lot about, Ollie. Like, basically as a company, especially as an established company, you're on a growth trajectory. So you basically, you grow, very linear way. And what actually gets...
Andreas cannot hear.
Andreas cannot hear us?
You might have to rejoin to hear us. I don't know, because I can hear you, Oliver. Rejoining helped. Julia says rejoining helped. Okay. He can, so, so Andreas, the entire time, Andreas listened only to me. So he looked at the slide and sometimes he heard, I agree. Please rejoin if you don't hear anything. I'll raise my hand if, as soon as Franz is talking, and do this. This is not meant in any despicable way, Franz, but I just need to make sure people understand that you're talking, so somebody else can say.
Do you have a hand puppy where you can actually?
Yeah, exactly.
Where you just move it.
But I can. Andreas can hear us both. Perfect.
Cool. Great. Okay, let's get back to that session. It's a really odd morning session, but I hope you're enjoying it. So basically, what's the point of going cloud native? So I think that's something that Ollie talked about. When I joined Giant Swarms, like really, you actually basically you're on a growth trajectory as a traditional company, and there a long time you actually don't see any competition, or not this ominous competition that suddenly then enters the stage, and as soon as you see it, it's already too late, because then basically it actually really overtakes. That's where you've got the exponential growth. That's where you see companies like Tesla or Airbnb or other companies that basically you're actually always keep feeling quite safe in terms of your, the changes you're doing, and they're, basically you've got linear growth, you're growing, everything is fine, and then suddenly someone appears in your what do you see, the back mirror, right? So as soon as you see them in the back mirror, they're already passed, and I think that's something where lots of companies are really thinking about, to do things more proactively, to really think about how they actually can set up the company very, very differently, copy the Spotify's, copy the Netflix, copy the model where, basically they're going through a huge transformation. And the challenging bit is naturally, that always hurts. It always changes a lot of things. But they are trying to actually really keep that level of disruption as small as possible. Because disruption inevitably will happen, and I think we've seen that in the last year quite significantly, right?
Yeah, and especially you see that this cloud native trend is really taking hold, and people that really have taken that for something they need to do, really changed radically, saw software development as a core system, as a core part of their business, really changed. Like one example is Adidas, who actually talked about it openly, hiring a lot of engineers and really radically changing how they do business.
And they actually have seen exponential growth, haven't they? In their online store, that actually went from the 14 million to 4 billion. That actually is like doubling every year.
Exactly, and it's really continuing. So let's see how that story continues.
Yeah, I think they want to bring like half their revenues to their online store. I think, right? Something
Exactly.
That's their next growth path. So that's basically why we're like, why are companies, why are business people thinking about cloud native? It's not a technology. Yes, it is a technology, obviously, but it's for them. It's not like they couldn't care less whatever you use. But it's really thinking about how you actually need to transition as a company, and how to make that very successful. And that's why I think we're talking about, like, if you want to operate Kubernetes, it's not about operation per se. It's like everyone can, if you can treat it as a software product, and you install it and you keep it running, and you don't care about anything else. That actually doesn't get you anywhere. And that's why we're talking about operating Kubernetes successfully, because this really has to do with how you transition as a company. And typically, we actually kind of, we actually know from companies that actually are trying to go the cloud native path, that basically what they want to do, number one is really increasing the development speed. Means that I can have my developers focus on building applications and not worry about making it compliant with the underlying infrastructure, making sure that it operates like with all kinds of dependencies, with all other applications, keeping it small, making sure that you can really build, test, build, run, test, and really get the measurements and the information for the improvement into the application as quickly as possible. And that actually also supports naturally getting things out really fast. So deployment cycles, making sure that you actually don't have to worry about all the infrastructure that is in place, but really focus on just building the application. That actually also helps, basically adjusting and adding that information back into the product and driving it forward. And that's like kind of the business side. It's like, move faster, be more agile, develop something that customers want, test it, verify it, and build on top. But then actually also make sure that every part is independent, so you can make slight adjustments. I think so far, actually, Facebook was my poster company for that, with 5,000 deployments a day. I just read 2-3 weeks ago that Adidas actually increased and now runs about 100,000 deployments a month, which just was mind blowing. I thought they actually went from once a quarter to a couple of times a day, but that actually number is really impressive. And then naturally, you've got the technical side, which is, the higher scalability. You can actually use cloud technology or your on-prem data center. Scalability is a bit difficult there because you need the machines, but especially the cloud environments, you really scale it up and scale it down a lot more. We had a customer session yesterday where they also talked about can we basically scale down our production or our development technology over weekend or in the evening, and then scale it up again just to save cost. And the other aspect is, making sure that you use the technology, like the cloud infrastructure, to create more resilience, making sure that basically you don't have any downtimes. And both last points are terribly important if you're in the retail space or where you're basically delivering services to your end customers that basically go shopping on Black Friday or a weekend shopping or things like that, where you actually would have consumers as customers, and you actually really want to make sure that if you're not online, you're not making business. And if you actually would otherwise do business like millions or in tens of millions an hour, that's the business that can get lost if you actually don't achieve the resilience that your customers expect.
And we're seeing that actually more and more with customers that are slowly figuring out that the mean time to recovery is the important part. So obviously there will be downtimes also with cloud native. That can't be taken away, and there might actually be more. Simply because if you move faster, you're also breaking things. That's not a question. But you're breaking parts of the system, and you need to make sure that only parts of the system break and the rest stays online, and you can still do business, like your payment breaking, but you still being able to close shopping carts and mail pay people later to finish their payment, or do other things just to make sure you're not losing business, and to have all the visibility for your teams to really be able to fix that very, very quickly. And that is true both on the development side, where many people, they will probably understand that you need to make sure that your developers know where the logs are and so on and so forth, and really have that agility. But if we really think about the entire stack, then Kubernetes is just software too, and it's the same thing. You need that same agility and roll out quickly and build new systems for your team and all the stuff around it. What do you do about CI/CD? How do you provide that visibility? How do you provide different services in the cloud? How do you do you abstract them away? And all that is just part of the same thing. You need to really figure out what to focus on.
Yeah. And I think there's one side, which is naturally the development side, where basically you need to think and prepare everything for. There's someone else who can't hear us. Can you probably just type in the?
Yeah, done.
Thanks. So the challenge bit. So the challenging bit is like in the development side, you need to get faster and build for that resilience. You actually need to make sure that you actually keep the parts really independent, that you keep them small, that you make sure that they can, once you actually basically pull up a new part, the applications can start very quickly. That you also don't think too much about how do I do what. You actually need to rely on the infrastructure team or the platform team basically to operate that. And that's the aspect we actually want to focus on today. Is like, what can I do as an infrastructure team or from the infrastructure side? What should I choose to make sure that I can be as agile as I need and use the technology to my advantage?
Yeah.
So
Marian, I'm talking again. I think you rejoined. Maybe you hear me now. Anyway, next slide.
Yeah. Okay, so I think that's something that you described, Ollie. It's like basically you it's just a line now because I actually didn't add, but it's like the time axis would be the x-axis and the y-axis is more the speed that you actually have when you develop. And I think what we actually observe across the board is you're basically linearly improving your development speed, but they actually it'll basically come to to a level where you can't move faster. And what you actually try to do is you actually transform the organization, introduce agile methodologies. You're basically transitioning. You're trying to rebuild the organization, build product teams, squad teams, whatever. There are like tons of initiatives across large companies, and actually, the smaller the company, the easier that transition. But what actually happens, you actually first of all have an efficiency dip. So your efficiency actually goes down quite tremendously. Everyone needs to get adjusted to a new system. You need to learn a lot. The organization needs to change. There are things where where things don't feel as smooth as they actually were before, and that's where you can then slowly get out of that curve and really go to a higher productivity level. But that's something that's that will basically happen over time. And as an infrastructure team, you actually really need to think about how you actually can help with that organization and that transition, because you basically run the infrastructure. You actually make sure that everyone can work very efficiently, and your job is really to think about how can you help the development teams to become more and more efficient going forward. So the idea is actually basically that you actually make sure that the dip isn't as deep as it often is, and the other thing is that it actually gets compressed in terms of time interval. So that's where you actually can accelerate the whole process, and you actually can make sure that you share your knowledge across the organization and provide it. So you basically have a short dip, but not as steep. And you could recover a lot faster and really adjust. So I think, can everyone hear us still?
Marian can now hear me, but not you anymore. I'll call Marian later.
Yeah, okay. That's strange.
I'll give you a call later, Marian. Anyway, yeah, and with any new innovation, that dip is there and that learning curve is there. But to really change that process and to really do that, you need to accept that dip and really figure out how to get through it quickly.
So yeah, I don't know how infrastructure teams really need to change, and I know this is like really black and white. I'm pretty sure that most companies actually would position themselves somewhere in the middle. Probably some of you maybe even all the way to the right, but we actually see that over and over again, while the personal perception of infrastructure teams is more to the right, the external perception of the infrastructure team is very, very different. And that's why actually most companies are looking for ways to get around infrastructure teams in many different ways. And that's something that we actually believe isn't very smart. And actually also something where maybe communication is not the best, but really the feeling and the understanding of how things need to be really needs to change. And I think there are like 4 areas we constantly observe, probably more you, Ollie, than I. But if you actually look at how you actually have the 2 worlds of development and operations, you put both together. You've got DevOps, then you add security, DevSecOps. So you actually have that kind of that process where both sides actually kind of approach each other and try to figure out something together. It's very easy to stay in an old thinking. It's like, yeah, you develop, you hand over, we operate, like who's supposed to do 24/7, who takes part, like, who takes care of what element, where's the failure? If something goes down, like, is it infrastructure, is it dev? So when do we pull everyone together? And what we actually see is that the complexity gets a lot bigger, especially with Kubernetes and all the surrounding technology and the networking. And then you have different cloud providers, and you've got greater dependencies. So you actually really need to work together very, very closely with the development teams to actually make sure that you actually have, hand in glove experience, and really understand, that's where we're thinking about the SOE model. There's the Google SOE handbook that also describes that very nicely, is where really the infrastructure team can take care of running something that that basically they know is highly tested, that they actually know is very, very reliable, and that they can actually also fix themselves, because it's very likely something that they have observed before. There are certain, let's say, thresholds that you naturally need to agree with the development team to make sure that you've got a good experience and everything stays up and you can take responsibility. But you actually also need to invoke the right development methodologies in terms of how do you architect this? How does the underlying infrastructure work? How do you start? How can you restart parts very easily? How can you make sure that the workload stays out, the application is resilient, if you actually make changes to the underlying infrastructure?
And we clearly see that with the customers furthest along, and it's always a challenge. But if there is a problem, it's always a multitude of teams being needed to really figure out what is going on, because we're moving to a time where this entire stack is actually relatively stable, meaning that the problems become complicated. It's no longer a clear delineated thing where you just say this is this side, this is the other side. It's some interplay of things. That's the complexity we're talking about. So you can't really, you'll have alerting infrastructure and you'll have monitoring infrastructure that makes sure the right teams get alerted. But you also need to make sure that the right teams can be alerted by the person being there in the room the first time. And we always have war rooms where we make sure like everybody's together in the room and we figure out quickly where to go. And if you then take that and really look at the last point, from the focus on operations to focus on engineering, the largest part is not the issue itself. The largest part is all that happens afterwards, because you'll figure out that in the software stack, there are problems that you need to focus on from an engineering side to make disappear. So you have some kind of dependencies that certain teams are not looking at the right metrics to see if DNS pods are moving, and they suddenly have DNS outages, even though Kubernetes told them how it works. So you have lots of different things that you need to have continuous learning, and we're actually moving with several customers to a method where we say every team needs to have a training every few months, because there's always new people coming. And as we talked about the dip before, you then say, okay, we need to start training early and so on and so forth. Then it feels like you're going out of the dip, and many people forget that the training needs to continue. And then you need to continue thinking about the mean time to recovery, and you need to make sure you don't fall back into your old ways. You'll have a downtime, and then you'll start, okay, who was responsible? The entire team, everybody. It isn't responsible. The responsible isn't with one group, and it's not who broke it. It's how do we get out of it faster, because next time somebody else will break something else. And I think that's really the important part to consider. You need to if you really want to go to a cloud native world, you need to understand that software development is becoming a core competence and not a cost center. Hence, how to develop software and how to get the right thing is important. Exactly. I'll go on the MTTR in a bit, Kubernetes is part of that software stack. So it's another thing you need to focus on and get that stack right. I still remember from early on, Timo, our CTO, always said the nice thing that the complexity from your product idea to the CPU is constant. You're just shoveling it around on the stack. And in this case, you're moving a lot of complexity to that Kubernetes environment. So you need to treat it as a software stack. Now, what we did previously is we measured downtime. But if we're moving to a cloud native way, we're also moving to a microservices, smaller services kind of thing, to an API driven thing, and so on and so forth. And that means that it's very unlikely that the entire thing breaks. It's a lot more likely that smaller things break. But due to having more things, it's actually highly likely that any one thing breaks at any time. So what you then need to do is you do something like service breakers and other systems where you say you make sure, as I said previously, like if your payment infrastructure dies, you make sure that you tell people, sorry, payment currently doesn't work. We'll send you an email when it works again. Your basket is saved. I don't know. It can still allow people to put stuff in the basket. If your search doesn't work, you still let people find the most sold products through other means, or you have a cache somewhere that shows it. And then you need the right metrics and the right logs for the teams to see the right thing to decrease the mean time to recovery, the MTTR. So if you accept that downtimes happen, then the question is not fully preventing them. Yeah, of course, you try not to have downtimes. It's not a goal, but you just accept that they happen. But if you accept that they happen, you need to make sure that you can get back from them as fast as possible. Meaning you alert the right people at the right time and the right teams. The people you alert, the DevOps mantra, you alert those people that actually build the product and understand the product, so they can look at the code or look at stuff they did, or look at logs, see what's happening, and are able to recover it to make it right again. This can be a rollback, but normally you actually say you're only rolling forward. Normally in this kind of environment, you're deploying multiple times a day, and whenever something breaks, you much rather look at what broke and fix it directly instead of rolling back to some previously known state that might have been very dependent on other states. So, and that's why I say engineering is the important one. Engineering in the sense that your team needs to know where the logs are, where the monitoring is, how the monitoring works, how the numbers work, how the alerting works, what to do in case of a problem, and really be able to save it quickly. And that is the large change. Previously, like in old times, the thing is tested for 4 weeks, and then it's rolled out, and if it fails, you just rolled it back to the old one. And that doesn't work anymore. Especially it doesn't work anymore if you deploy 20 times a day. And that's really what you want. We actually see some companies moving in the direction of not even having some kind of staging. They have dev, they build there, and they move directly to production. They might have something for load tests, but really the goal is to move directly to production. Okay, good question, Andreas.
I'll just read the question. What's your experience with developers acting as operators, like getting up at night to fix something? I've seen that developers and operating people are very different animals.
Yes, they are, and hence you need the right people. The first thing they need to understand is that if they are only responsible for their stuff and to fix their stuff, not the entire shebang, then they actually have control over being alerted. And that's something they need to accept. Like you can't have developers be responsible to fix something they didn't build. That doesn't kind of work because they might not even understand that part, and so on and so forth. And old operations people kind of find a way around it. Hence, you really need to focus on making them understand that they're responsible for their bits and pieces, and that they need to fix their bits and pieces. And then we have seen it working very well. It is still challenging from time to time, especially like we have platform teams at different companies that can really save a lot of stuff and that know the monitoring and logging infrastructure often a lot better than the developer. But that's what I mean with the training bit. You need to make sure that these developers understand what to look at if something fails. How do they get to live logs directly? How does the platform team build a setting that they can get to these logs, that they can fix it? And in many cases they can't. In many cases they don't even know. They just sit there and say, well, my monitoring says there's a problem, but I don't exactly know what. And that doesn't work. Hence the training together and figuring out how to give them all the systems they need. If ITIL isn't relevant. No. No. It's very relevant that it was a joke recently with one of our customers. Like we had a problem with the downtime, and then now we're moving back to ITIL and change management boards. Like you don't want the fun thing is that some people use the change management board to really make them understand that it doesn't work because they'll bombard them with 20 deployment requests every single day, and the change management board sits there in the entire day. Of course, some things make sense. I have never studied ITIL, so I don't fully know the entire process. But you still have monitoring and alerting, and if something breaks, it's an incident, and you need to. We have an incident tooling actually within our Slack, Incident.io, that allows us to start an incident in Slack. It directly creates a document where we can write stuff in. It directly starts a meet link where the entire team meets, and we really try to figure out what were the last changes. You need to log the last change. You need to be sure like what changes have happened in the last few minutes. Is there something that might have led to that downtime? So you can look through ITIL, might actually be a fun process, and really figure out, can we do that and use that if we deploy 500 times a day by 30 different teams? Does that still work? And what still works? Because some things still work, you still need to log changes. You still need to have incidents. You still need to talk. You still need to improve. But it's not such a rigid system. And I think that's the important part. I always joke that software development is communication. Hence the primary thing is having people talk. And sit in the group together and figuring it out. Yeah,
it's more the cultural change. It's like, it's you actually, if we all would follow processes, probably nothing would work. I think that's kind of something where I think that's where you actually really need to have this cultural change where you both take responsibility for something. You actually figure out what do we need to monitor to actually identify if something's going wrong or right, to have really, clear logging, have clear separated access to all kinds of information to actually make sure that you can really figure out productively what happens, not point the finger at each other, but really figure out what is the solution we actually want to, like, that's what meant with, metrics on activity. It's not, it's not about like, I actually had like 100 support incidents and we solved them within like a mean time of resolution within 30 minutes or something like that. That just doesn't top the goal isn't like getting that number down. If you actually keep a system stable, if you don't make deployments, probably you will have the best results as an operations team. But you actually really want to make sure that you actually support change. That you actually make changes happen, and you can't do it manually. Like that's where automation comes in. That's where you need to make sure that you cover as much as possible through automation, and you actually you focus on changing your teams to be like programmers instead of like installing apps and maintaining them within a certain realm of. So you actually really need also different people within the infrastructure team in terms of mindset, and that's where the cultural change comes in. There's another question.
How do you ensure comprehensive automatic testing if you want to deploy 500 times a day? This obviously doesn't work manual anymore. In old boring or idle times, you had various manual user exception tests, integration tests, which took time, days and weeks, not seconds. Yeah. So once back, we are ISO certified, so I know a little bit about these ISO processes. And we changed a lot of things in there to make it reflect how we work. So you can mend these systems. And yes, you don't do these full tests, but the difference is the difference is that you no longer have this one thing you deploy that you need to test. You have 20 different things that you deploy independently. And you try to deploy so often with so minimal changes that any problems are easy to detect and to recover from, mean time to recovery. So you obviously have automated tests that stuff doesn't fully break, but stuff will happen. We recently had a problem because there was a space in a configuration file, entire site down, or like parts of the site down, and there was just a space. Happens. You just need to be able to find that quickly, and hence you need to make sure that your changes are minimal. And you know which changes happen, so you have a faster way of figuring out where the problem might occur. And that's what we're always working with our customers, making sure they use open source tools that we have in our catalog that they can use to easily build up their first monitoring and alerting, and really figuring out what their infrastructure is doing, and really figuring out what the last deployment was, and then going in there and seeing what the changes were, trying to do minimal changes, not wait for days or weeks to do the next deployment. And then you have the big thing again, and if then something breaks, that's painful. So the longer you wait, the more you probably want real manual testing. If you do it bit by bit, then it's not so much needed, and then you can obviously do other things. You can do A/B tests in the sense that you comprehensively build the thing so that only 5% of your traffic goes to a new deployment and 95% to the old one. That's something you could do to see, like some companies do it that way, that you deploy the new stuff next to the old stuff and look at errors coming, and then figure out, okay, like the errors on the new stuff is higher than on the old stuff, hence we roll back. And rolling back just meaning shift over the traffic again. But that always sounds great, but I have to say that mostly I'm with Franz in terms of it being a cultural change first and foremost, and just starting. Take a first team with an application that is currently driving you nuts because it's just not performing well, where you have an easy win, where the business doesn't die if it fails from time to time, and have them work that way and figuring it out internally and become internal champions, and then iterate from there. You won't go to automatic A/B tests and everything automated from 0 to 1. Doesn't work. So really bit by bit, it's a continuous learning thing. Now we go to learning organizations and whatnot. I mean, there's lots of material to read up on. But
that could be another webinar, right?
The learning organization. I have to dig back up all my MBA stuff. And I think that's the hard part. And the hard part comes when shit hits the fan, like when they deploy something new and something breaks, and you say, okay, we took too long to recover, and you don't start blaming that something happened, and you don't move back to change management boards, you don't move back to more tests beforehand and so on and so forth, but rather move, okay, we need to deploy faster, we need to deploy more often. If it hurts, do it more often is another wonderful saying.
Yeah, but that was a great discussion. And Andreas, we might invite you on stage later if you've got a couple of minutes and if you want to. So think about it. But yeah, I think in the interest of time, we've got about 15 minutes left. Actually, I would just suggest we go on a bit, and then if there are any questions, we're more than happy to also set up a separate session or stay on a bit longer to actually discuss this in more detail. Yeah, I think these are just examples that I put together and just to rush over them a bit. One is the complexity and the dependency, and as you can clearly see, you've got all kinds of different stacks where you've got the physical infrastructure, the virtualization, then the management cluster, or that then orchestrates the workload clusters. And yes, you can abstract a little bit away from that, but basically, if you want to fix something, if as Ollie said, shit hits the fan, you actually need access to many different areas to speed up the process, to make sure that basically there are people there that can immediately put attention on something, because in many cases it's not necessarily the application, but it's something in between. It's it's not the service that is deployed that might be part of the problem, like filling up logs or or space and stuff like that, but really making sure how you can how you can sit together in a room, figure out what the problem is, get it restored, and make sure that you actually constantly learn. Yeah, and as you can see on the right-hand side, it's many times you actually have the data center of the cloud provider that basically takes care of the infrastructure layer, but then you've got a huge stack that reaches into the containers, where you actually then need to think about how you actually want to run and offer apps, standard apps like monitoring or security or service mesh or other things to your development teams. And then you actually still have, let's say, something like a platform team that goes out and educates and advocates for the platform within the project teams, so they actually can then better use and develop technology or their applications and their services, microservices, for the underlying infrastructure, or using the capabilities of the underlying infrastructure. Because it doesn't make sense to actually, there's lots of technology already provided that you actually can just reuse if you provide it as a product. And that's the engineering aspect, that the last item on the previous slide that we talked to, really developing products that people use, and really focus on what do the development teams need and how can they use it without building up tons of knowledge about how to fix it or how to run it, really educating them as they're going along. And I think there's something I actually picked up on Twitter sometimes, really a puzzle set with thousands of pieces, and then even in there you actually have lots of possibilities to configure something. So if you look at an infrastructure team, yes, you can actually focus on this box on the left. You probably can't see my cursor, but if you actually go to the second block on the left, that's where it says Kubernetes. The rest is all applications around, either that you necessarily need, if it's an etcd or whatever, or you actually can install and provide that to your development teams. And that's where lots of infrastructure teams fall short, because they are understaffed in that respect, because they actually don't have the time to figure out, what's, let's say, what solutions are there for monitoring. It's you actually tend to go with the monitoring that you actually used in the past, or you find something out about a new one, but you actually, there are so many levels in there that actually can give you more granularity. How many times have we heard that someone notified us about a problem because it showed as a problem, but we couldn't, even with the right people within the customer organizations, we couldn't figure out what the problem was, because they actually didn't go to that granularity. And that's where it actually becomes really, really difficult to be very effective. And that's where you really need to think about how you want to either cover this internally or externally, and make sure that you can really enable and empower your development teams to move forward really, really fast. Priorities is naturally on automation. I think that's part of where we quickly talked about the manual toil. So anything you actually do twice, you should automate. And a very good example for this is, where you basically have, the Kubernetes clusters, and you've got your management cluster that, you basically either deploy or you use from someone. But then you actually need to build up these clusters over and over again, and you need to maintain them, and you need to make sure that they actually keep the status and automatically reconcile. And then you've got different teams, and then every team actually adds their own applications on top if they want to. And and that's where the infrastructure team typically says, well, we actually can provide the base, but the teams need to, if they actually want to take care of the apps, or if they want to install an app, they need to take care of that themselves. And this is where it gets really highly inefficient, because there's a lot you can build in terms of automation. We've built for the last 7 years automation around it, so we can actually really manage multiple clusters. So we actually, when we actually were founded, we actually knew we actually would manage Kubernetes for our customers. So we always built all the automation into the extension that actually would allow us to manage it at scale. So we've until recently, we actually had single persons managing 200-300 clusters 24/7. And that's where you actually need a lot of automation, lots of reconciliation. And even then, there's like tons of other things that you need to get to take care of, because they can just go wrong. It's a wrong policy, or an update in an app that actually starts breaking, or you've got a traffic dip or whatever, where you actually need to figure out why it's there. And probably, Ollie, you have got plenty of stories to tell about how we actually figured out things and then basically automate to get rid of them.
Yeah, and I'd actually try not to fully focus on the problematic part, but it's also we have people that can launch a testing cluster with the entire CI/CD and just start a cluster from scratch, deploy everything in it, run their tests, and turn it off again. We have projects with big data stuff where people might launch clusters in the morning and pre-warm things to be ready for the data engineers later, and turn them off again and have it fully in Kubernetes, so they can theoretically do the same thing on premise as they can do in the cloud, and really run it everywhere, depending on where the data is that they need, because data gravity is probably the hard part. And what we always try to do is get to the root of the matter and really try to fix it in the product. So same with your product that you're building, we have a fully versioned system. So if something breaks on one customer, we fix it once and then deploy it for every customer as a new version, so we don't see that problem again. And that versioning is the same thing that everybody would do for their applications. The difference is that in this world, infrastructure becomes code, and hence it needs that same versioning, and that's where the power comes from, where you can really automate the entire infrastructure and not really care and set it up again from scratch if you need to. So I really think that's the important part to remember.
Cool. I actually also found this one here naturally, and that's something you really need to figure out. Is Kubernetes comes with a cost. And the cost is really having people that can take care of all these different applications, taking care of the developers. And it actually starts with a single project that might need Kubernetes or might want to use Kubernetes. And that's what we've seen over and over again. It's like you've got lots of upfront investment, and then naturally you need the people that actually can manage it at scale. But like the projects take a long time to actually come onto Kubernetes really at full scale. And that's where we actually see, again, where lots of money actually gets flushed down the drain, is that, everyone actually tries to get Kubernetes ready, it's already deployed, ready working, check, done. And now, but development teams aren't using it or the product teams aren't using it as intensively as you would expect. And the mismatch here is that no one really takes care of educating and taking their teams, making sure that they can use the infrastructure as they should be using it, and deploying it across the organization. And that's where basically the speed costs a lot of money, or the lack of speed costs a lot of money for the organization. And here it says size of org. I don't necessarily think that you need to be a big org to use it, but like you need your team is fully committed to it. You need to be able to fully commit to developing the cloud native path. If you actually, if you just want a Kubernetes checkbox, then it probably
won't work.
Yeah.
Yeah, and we actually have a new question from Stefan that is fitting. So because it's a longer one, but I fully agree. Let me just quickly paraphrase for those that are not reading the chat. So Stefan heard of 4 ways of DevOps in companies, and I fully agree. Of course, you have the old classical dev team, ops team, and then they just rename one of them to DevOps team. By the way, Stefan, what happens now is that they rename them to SREs. It's still the same ops team, but they're renaming them to SREs because SREs is even hipper than DevOps. Yeah. So that's one thing that we also see happening, but it'll fail. Then you have the classical division, and you have a DevOps team to create tooling. I'd actually say that we see that a lot, and I to a certain extent I put the platform team in that system. So what we have, like for our customers, we provide the Kubernetes, and we provide many of the apps on top. But the big ones all have platform teams that make sure that, like, how does CI/CD really work? How is security really integrated? How does monitoring really work in our case? Because we can provide you monitoring, but you need to decide which data you want in there, and so on and so forth. That build the tools for the other teams. And while they're not a DevOps team, they're often a training team. They're often a knowledge team, a tools team. But a tools for the other DevOps teams. Then you have the third one, the classical division of development operations team, where the ops team operates the platform, giving the developers a chance to do deployments, and so on and so forth. Yes, I think that's to a certain extent this, which I like from the Google SRE book, in terms of the platform team, or even us being able to run the software developers build, unless we hand back the pager if something really breaks that we can't fix. Because again, if you, I recently said with that chasm you have like waterfall software development, and then you have fully agile. You can't jump halfway. One of our customers recently said that many people do water scrum, which I still think is my favorite term, because it's so correct. And the same thing, you really have to move the full way. The Dreamland is your fourth one, is the develop team fully autonomous. And I agree that's the goal, but I think especially for a bigger organization, it'll really, really, really take time. I'd say what we see mostly is having an internal, let's call it DevOps training team, in our case, platform team, that enables the teams to go deep into the stack and really become a full DevOps team. So the goal of that platform team is to allow teams to just have APIs, deploy at will, and so on and so forth. The problem is that platform team also has to do the training of the management and really make the management understand that they need to allow people to just deploy. And then comes if it's a real DevOps team, they do 24/7. That's for some companies just too expensive. Big telco that can't do 24/7, they just can't. They're based on
legally
contractual legal things, they can't. So then you have a problem. Then you can't really do full DevOps. I think it's a continuum. I'd love to give you a clear answer. I think the successful ones we're seeing, and I'm really thinking through a lot of them at the moment, is really that you have an internal, like we have, Another one actually has an operations team and a team that builds stuff that the operations team can use. And they still have DevOps team, but the operations team makes sure everything is running and get the right teams in. And I think that's the one you see most. That you have a platform team, a whatever team that makes sure the right people are getting online. And I don't think I can put it any better. I'd love to be able to say like a developer team that is totally autonomous. No, not the case. Many people are just not there yet, especially because I think the psychological change is so big. The change in terms of allowing them to deploy as often as they want to, and allowing them to be fully independent and really do that. And then possibly actually have, in Germany you call it the Fachseite, like really have the business side in that team developing the features, measuring like if the feature they just built really provided more revenue or not. I mean, if you really want it the entire way, then you have mini companies inside your company. That would be a totally separate one we could talk about, like what does the company of the future look like? But okay, I'll stop now. Thanks, bye, Marian. Thank you for the question, Stefan. Great thinking about it. And yes, I'll just copy out the division in 4 different parts because it's perfectly put. Andreas has another one, or a saying. In my view, the services that used by several Scrum teams should be bundled. Shared service team that typically looks after the platform, but also commonly used topics like incident management, overall monitoring. DevOps teams are then on top, application specific also providing second and third level support. The right balance between what is specific and what is shared depends a lot on complexity and size. And of course, how much you have to interface with the legacy IT, which is usually the biggest topic in large enterprises. Yes, that's actually fun. The legacy IT world, like we have teams that are fully onboarded in Kubernetes and they're still waiting for 4 weeks for their OIDC access because the old IT organization can't give them access to an Azure AD, whatever. When that clashes, is really interesting. So we really try to abstract that fully away, and that's what most people are fascinated with. I recently talked to somebody at one of our customers that started with us like 5 years ago, and he said it was so mind-boggling just getting his Kubernetes access and just being able to start stuff up and do stuff and having internet access and having like live things to deploy. Without having to request servers and so on and so forth. So that's really, really important. And I agree with the shared services team. That's probably shared services platform, whatnot. That's what I tried to say. You have like, and it's partly that by Andreas, and it's partly that you have that central team, like the SRE team at Google, that will make sure it runs if they have full control of it. Once something breaks they don't have control over, it changes. I'm done.
Good. We're already 2 minutes over the time, Ollie. So I actually don't know if we should kind of skip the rest, or if we should,
I think we learned a lot. I learned a lot.
I actually, that's why I didn't want to interrupt, because these were great discussions. That's why we're here. It's really to have these discussions and not just speak.